Hello and welcome to this vSuite version 0.4 video tutorial, and in this video tutorial I'm going to cover how to do or how to apply what are called normal maps with LiVi to be used in Radiance lighting simulations. And this video tutorial is basically a follow-up to the Radiance Patterns video tutorial. So before this video tutorial, it's a good idea to watch the Radiance Patterns video tutorial. Now, from the Radiance Patterns video tutorial, you're hopefully familiar with this workflow and this sort of node setup I've got here. I've just got a simple plane within the scene. I've got two lamps, one pointing downwards and one pointing upwards, and those lamps have an IES file associated with them as per the artificial lighting simulation tutorial. And this plane has an image associated with it, an image that can become a Radiance pattern when we do a simulation in Radiance. So if I have this plane selected and I just look at the material I've got associated with this plane, which is this text material, then from the Radiance Patterns tutorial, in terms of sort of setting it up within Blender, I've just picked a diffuse BSDF material. Remember that for this workflow, this patterns and textures workflow, we should be in the cycles rendering engine rather than the Blender render that we start with by default. And once we're in the cycles rendering engine, then we can select what kind of material is associated with this plane. And I've just picked a diffuse material at the moment, like a plastic matte material. And then I can change the color of that material to an image texture. And I've selected my tiles image. And if I just pop into my image editor and I go to my tiles image, then let me just get rid of these menus. Then if I hit tab to go into edit mode, I hit U to unwrap, we can see that that plane geometry has now been overlaid over that image. So if I was to move that, we would see, for example, the image move in terms of the mapping on the plane in the 3D view. But I just want to have the plane mapped perfectly to the image right now. And once I have UV unwrapped this and mapped an image to it, then I have for that material and for that plane a UV map, the name of which is defined down here. And once that is done, as long as I have textured or material viewport shading selected, I can see that image applied to that plane. And so I can, in my vSuite node setup, I can export that geometry, and I can now preview that from the perspective of the Blender camera in Radiance. And we can see I have one IES light shining down, one IES light shining up, and we can see that image appear on the geometric plane. But it's a flat image. The plane has no complex geometry associated with it, it's just one face, and so when we light it, the face looks flat. But if we are lucky to have a normal map that goes along with that color image, then we can apply that normal map within the vSuite, and we can simulate it in Radiance. So I'll just explain very quickly what a normal map is. These are normal maps, and often if you download a set of high quality textures, then that texture will come not only with the diffuse color, but it will also come with a normal map. And that normal map uses colors within this image to define the direction a surface is facing for each of these points. So if I just scale in a little bit, we can see there are different types of normal maps, but in this normal map we can see that here, for example, the map is green. And we know, because of these stones and the recessed mortar between them, that this part of this stone is pointing upwards a little bit. So we know that in this normal map, which is called if you see a normal map which is mostly blue or bluish, then that's called a tangential normal map. And so we can see that green signifies how upwards a point on this surface points effectively. And we can see that if a part of the surface is pointing to the right, it's red. And this is called, I think it's called a sort of OpenGL normal map, and it conforms to OpenGL specifications. Green is up, red is to the right. We can, however, also have, let's see if I can find one here. There's one. We also have a different normal maps. They do the same thing, but in these normal maps, green, instead of pointing upwards, points downwards. And that's, I think, a sort of a DirectX compliant coloration of a normal map. But red still points to the right. Unfortunately, we can use both within the vSuite, but it's important that you know which one you have when you specify the mapping of the normal map to the surface. So if I come back into Blender, in my image editor, I can see this is my tiles diffuse coloration image, but I've also got here a tiles normal map. And this is the OpenGL version where green points upwards and red points to the right. So what I'm going to do is I'm going to go into the node editor, but instead of using one of the vSuite nodes, I'm going to use the material node editor for this currently selected text material. And in this node editor, I can see that I've got a diffuse material connected to my output, and to the color of that diffuse material, I have an image texture node, and that image texture node contains the color map. But what I want is to associate a normal map also to this image. So we're going to plug into this normal socket here on the diffuse BSDF. We are going to add a normal map node. Going to connect that normal map into there. And we're going to select in here the name of the UV map that maps the original color image to the plane. I'm going to keep this on tangent space, and in Blender we could alter the strength of the alteration of the normals on the surface if we wanted. But for the vSuite and the Radiance, we'll do that somewhere else, and I'll show that in a minute. So into this normal map, we also want an image texture. And this image texture, you can either open up the normal map directly, or because I've already got it selected within Blender, I can select the normal map image that corresponds to this color map image, and I can drag the color into my normal map. Sometimes we might pick non-color data, but if I remember rightly, for this particular normal map, either works fine. So once we have that node set up, the vSuite can interpret that node setup as a normal map to be applied to a Radiance surface. So down here, we've, within our vSuite material box, I've selected this material as also being diffuse, a plastic material. And by default, materials are grayscale 0.8, 0.8, 0.8. But what we want is that to be 1, so that this material doesn't change the color mapping. So we're basically multiplying this color map by 111 in RGB. And that gives us what I've showed you before, the Radiance sort of pattern of that image on that surface by having this textured button selected. We can now, because we have this node set up here, we can now press Normal Map. And this option has appeared in version 0.4.9, I believe, or the latest version available as of today, which is the, what is the date today? 20th of April 2017. So once we've selected Normal Map, we can sort of analogously with this strength option here within Blender, we can set the strength of that normal perturbation within Radiance. I'm just going to keep that as 1 at the moment. And we now also have to set the direction of the green and the red elements of our normal map image in terms of Blender 3D coordinate space. So this is important when we've got different types of normal map. So if I just check this normal map, this is a standard OpenGL one where green points up and red points to the right. So here in my scene, my green channel is pointing upwards, and upwards is positive Z in Blender global space. So I would want here, which I've already got, 0, 0, 1. So it's pointing upwards in Z. And the red is pointing to the right, and the right in global space is positive Y. So here I want 0, again already set up correctly before, 0, 1, 0. So 1 is in the Y-axis. If this plane was rotated around and the right was actually pointing down the Y-axis, this would be -1. Or if it's rotated at 45 degrees, then in the X and Y, then this would be 0.71, this would be 0.71. So you just have to specify the direction as a vector for your green and red channels. So this means that a particular material with a normal map associated with it will work for planes or surfaces which are all kind of orientated the same way. So the green channel of the image points in the same global Blender direction, and the red channel of the image points in the same global Blender direction. So once that is done, I can now come back into my LiVi nodes. I can export. It takes a little bit longer now as we process the texture map image into a format that Radiance can understand. And now I can preview that, and we should now see that instead of getting a very flat plane with flat illumination on it, we now have these highlights. So we can see that in terms of the lighting, we haven't changed the geometry of the plane, but in terms of lighting, the normal map has changed the direction that Radiance thinks these points on the surface are pointing. So these points here, which are pointing downwards, they would have had a low green component. They're picking up more lighting from this light down here. Same here. This is high green in a normal map, which means it's pointing upwards, and so it picks up more illumination from the lamp at the top here. I think that's basically everything I need to cover. Yeah, I think so. So it's a fairly easy way of, you know, if you're lucky enough to have a normal map associated with your image, or it's possible to generate normal maps from photographs. They may not be particularly accurate, but it's a way of, if you can get a normal map or generate a normal map, it is a way of introducing sort of bump mapping or surface texture within the Radiance scene, which, a bit like Radiance Patterns, may not be that useful for numerical lighting simulation, but if you want to do a sort of presentation renders with Radiance, then it can be very useful. Now I've got this feeling there was something else I wanted to say, but maybe there isn't. No, I don't think there is. So yeah, that's it. Thanks for watching.